Here we will discuss how to run Python-based machine learning models in Mat3ra platform. The easiest way to get started is by importing an existing workflow from Mat3ra workflow bank. If the desired workflow is not available, we can create a new workflow and select one of our available ML templates. If neither the workflow nor the template is found, we can always start from our general-purpose Python workflow and provide our Python code and dependencies. Now, let's switch to platform.mat3ra.com and see how these various options work in practice. First, let's explore how to import an existing workflow from the bank. Navigate to the workflow bank and search for Mat3ra. Before we can use these workflows to create a job, we need to copy them to our account collection. Once copied, they will appear under the Workflows tab. We can open a workflow to inspect and edit it to our needs. As we see here, Mat3ra total energy workflow consists of 3 units. The first unit, I/O material, gets the material data from the job context. The result is an array of materials. The second unit takes the first item of the data array and assign to another variable named material. Finally, the Mat3ra unit uses this material definition to predict its total energy, stress, and other properties. Besides the main input script, the Mat3ra unit also has a utility script and Python requirements file. We can add additional Python packages to the requirements file if needed by our Python script. Once happy with the changes, save and exit the workflow. Next, navigate to the Job Designer page and click Create New Job. Let it be under the default project. As we see here, the Jobs page consists of 3 sections: Material, Workflow, and Compute Parameters. For this demonstration, we will select Nickel Slab as the material. Then we can select the workflow, which in this case is the Mat3ra workflow we just imported. Let's rename the job to Mat3ra Total Energy. Depending on our compute needs, we may adjust compute parameters such as cluster, queue, number of processors, time limit, etc. Finally, save and exit the Job Designer page. Now we are ready to submit the job for execution. Once the job is completed, a summary of output properties will be shown in the Results tab. All input and output files are available under the Files tab. We can preview or download them for further analysis. Next, let's move to option 2. This time, instead of using a pre-existing workflow, we will create a new workflow. Let's call it Cell Relaxation, Mat3ra. Select Python as application. Add an execution unit, edit unit, and select Mat3ra Cell Relaxation Flavor, categorized under Machine Learning Force field. In this case, we do not want to get our materials information from the job context. Instead, we want to define it using ASE library for demonstration purpose. Here we specify gallium nitride with wurtzite structure. Once the workflow is created, we can create and run jobs same way as we did in the previous step. In this case, a side-by-side comparison of initial and relaxed structures is shown in the Results tab. Initial and final structures are also saved in CIF and POSCR formats, as listed in the Files tab. Next, let's discuss how we can run our ML models using GPU acceleration. This time, we create a job using Mat3ra Phonon dispersion workflow. For debugging purpose, we print whether the job is running on GPU or CPU. Most importantly, in this case, we have to select one of our GPU queues, such as GOF under the Compute tab. Once the job is done, both phonon dispersion and phonon density of states plots are shown in the Results tab. We can open the standard output under the Files tab and verify that the job is indeed ran on GPU. Finally, let's discuss how we can run any other Python-based machine learning model that is not available in Mat3ra platform. In that case, we can select our general Python template, specify all necessary dependencies in the requirements file, and write our Python script accordingly. As long as our ML model is Python-based and dependencies can be installed using pip, we can run it in Mat3ra platform. If your model can use multi-threading, you can specify necessary environment variables on top of your Python script. Now, please visit platform.mat3ra.com to try it out yourself. Thank you for watching this tutorial and using Mat3ra platform.